Now let's continue with our journey into AI infra. So into our next session, we have Sally Lee from Uber AI team to walk us through the model lifecycle management quality assurance at Uber scale. So Sally, the stage is yours.
Hi everyone, I am Sally. I am from Uber AI platform. So hopefully I can give you more insight about how Uber does for you. But before I started, I want to know about you and also along with the question about how much you know about Uber. So can you guess what is the 25 million, which is number related with Uber, and along with what is your engineering role? Are you a software engineer or machine learning engineer or the data engineer? I want to know more about it so I can help you better in my presentation. Can you have it and given a hint about you? And if you have a guess about the number in 25 million, what does that mean for Uber? And that would be really also helpful for fun. Anyone? No, none of single one guess? Yeah. Okay. So Ahmed is the one for it. Yes, we do have. 25 million parameters. That's a very creative answer. Okay. Yeah, I expected in this is 25 million is the one for an Uber has per trip. So in the way of the Ahmed has that a kind of right answer at the first, and then also number of requests is much more. And I will give you an overview of that at what Uber does. Give me 1 second, I can do the view. So hopefully most of you are the one that AI as a beginner or in the knowledge of it. So I can more focus on, okay. So I am kind of working at AI platform, especially I'm responsible for that lifecycle management, which is orchestrating all the ML pipelines, as well as that ML quality part at Uber. Today, I hope if you are the ones being software engineer or either in a machine learning engineer, you will learn about it, how Uber does, and then also you can bring up this idea to your work. I cannot see the chat channel during our presentation, so if hope you can help, and that would be great. And if you have any question or a lot of questions, and you can stop it, and also I can answer for those first. At Uber, we have a lot of examples, which is data is in our ML conferences is quoted, and Uber is a giant machine intelligence problems. So I hope that once you have it in Uber trip in your life cycle, in your lifetime, and I expected in those one, and you already interacted with a lot of machine learning at Uber. So meaning is that for a few example I can give you, which is if you are in the delivery businesses, when you were a delivery app, you opened up and everything is being recommended for you, and using all these machine learning platform. And for our driver partners, we also have a lot of vision computed, where during the pandemic we detect whether driver partner has wearing a mask to save for the rider and driver. And also meanwhile, and we also have that one is being surging area being forecasted beforehand. So helping a driver partner to be in the better position and rider in a less surging area. And you can see the rider can trip in advance with ATA's estimation. We have a bunch of ATA, which is Ahmed has a number of trip requests, where number of trips, and then whereas the number of trip requests are going to be that very higher level, because some of them is also canceled that. And behind of it, we also have a lot of detection in security reason, which is fraud detection, as well as the risk model being running for driver partners and then riders. So everything is being powered by the ML at Uber. So you will think about it, hundreds of models are being actually trained every month and then deployed it in production and being used. A lot of requests, which is tens of millions requests per second happen for online prediction and then feature store. I can go about it. What is a feature store means to you. And then also 100% of them, I'm really, really proud of that. We have it in code as Michelangelo is our AI platform, serving all of critical business models at Uber. Okay. Before jumping into Michelangelo, I can give you a heads up on like what is a landscape in ML platform. So if you are a software engineer, it hasn't been started in AI platform, or if you are the data engineer, which has been started, you have a lot of big landscape in each area where you can contribute it in AI platform in now and the future, and even more needed on the infrastructure part for the AI platform. And you will see in the middle, there is that ML code. Yes, this is a core, but then all these challenges in surrounded, big. Prior to kind of Michelangelo, you can imagine that I joined at Uber and now it's been 7 years and I see that all the life cycle of growing with in AI platform at Uber. So before without platform, and our data scientists actually downloaded data from our data lake and then train the model with your notebook. And then with the trained model, they cannot productionizing it. So yeah, Jeff, you have a good question. We have it 100 of the model. Because one of them is we have it in big problem spaces. So model itself or the model use cases itself is really large at Uber. So you are interacted with one single chip and powered by that a several hundred model behind of it. And so we still have that once being 100 models in served at the same time. But in the meanwhile, and we also have that some models, which is country or city based and prediction happening and so forth. But this is right. We have it in bigger trend of it by starting and transform into the deep learning model and multitask model. And that's that a kind of right trend. We also pursuing it. Michelangelo is also following all the sequence of it. Big box in a feature engineering, what we are going to go over. And then also model training is yet another big area we want to do, kind of tackle it. So then 2016, we are really getting to that business and then having a model being more reliably training and then also big data processing. And after that, we get in advanced on the model and then get into the operation area and unlocking for the monitoring and so forth. And at the end, we have it end-to-end lifecycle management. And now we are doing that once being really on LLM lifecycle management area. Few questions come. Yeah, so how big in Uber's ML team is that around like 70 people in us? And we have it in more open source project based so that you will see that once we much bigger community, we get it on all of that ML community resources in out there are going to be kind of actually helping for us as well. And yes, I will go over that Sarah's question. We will, I will go over that once we model training shortly and will be, but it's the Kubernetes, yes. So this is the one how big infrastructure we have. You can see that once being lower level is the infrastructure. Low level infrastructure, what we are using, OCI and Google Cloud or on-prem services have been all available. And in the middle, and we have a big architectural, like 3 sections, where the feature engineering is the part of the big data processing. And then model training in this video, model training happen. And then model serving is the one that inference in large model serving and reliable model serving is happening. Okay, one quick question is that how do we handle model training across environment? Yes, that one is going to be, I can go over in the next, thank you. And on the top layer, you can see that developer experience and production experience. This one is that actually the area what we have been interact with the user, but in the middle part is mostly an abstracted from the user, so by our platforms. So in Uber, if you join at Uber as a machine learning engineer, you will get access all of the implementation what we have and abstraction layer. So you can have that little bit of interface. You can build easy, a simple model through UI experience, as well as that a few configuration. You can creating that deep learning model and testing, and then few interaction. You can also building up that features as well. And all of free, and we can have that one screen quality of the system as well as the models coming too. So yeah, the generated AI is not in the picture in here. Generated AI gateway is the one for that we have. Generated AI is a 3 area, which is commonly in that ML model. We do kind of holding in house, but whereas the generated AI is the open AI or either in that external AI services, which is Azure and so forth. So we also have a gateway for accessing LLM model in outside of Uber. So that's the gateway. Cost of one thing is the cost of managing AI ML infrastructure. Yes. Yes, that one is being kind of not, Nirav has a really good question. And we also have that tackle for those. So unlike in Meta, I think in sooner it's going to be Meta will be presented. And we do have it a lot of workload and then cost aware in every single at Uber. And then even more, we have a Google Cloud. And so we have it in the infrastructure part is that enable that all the cloud. And at the same time, we do have it and very mindful about that lowering and optimizing the cost. So it will be we call that one as being training part, and then serving part is a different tackle. So I can do kind of talk about it, a touching point for those one in training part. So if I go with that overall ML life cycle, then you can think about it, it's very iterative. So earlier it was that machine learning is being built by the algorithm and that's it, but it's no longer. Because if you do kind of build Uber like businesses, which is that huge ML models behind of it, it is supposed to be very iterative and reliable. So it has a 2 big iteration happen. So one part is the one that development iterations, and the second part is the production iterations. So you will see that once being all the job roles are different, which is the data engineer is interacted with that and all this feature engineering part. And then applied scientists, we call as a data scientist in this area to go through all the hope. And then ML engineer is working, which is commonly in charge of the end-to-end. So ML ops is commonly we do kind of fit in machine learning engineer. So ML engineer is the one for that. And production side, and we do have it interact mostly on that applied scientist, software engineer, and ML engineer. This is kind of at Uber's landscape. How does the question for the model performance? Yes, that's the one that we do have it happen. So in model performance degraded, and yes, we do have a trigger the retraining to refeed the model in the recent data. That one is really common problems at Uber because Uber is moving very fast and world problems is the one that at Uber. So we have to do that once being all the data dynamics everywhere. Yes, we do have a data scientist. It's more on the data research scientist at Uber, and then applied scientist is more about it, apply that machine learning problems in a business use case. Okay, one last question before it. How are the model observability KPIs? Yes, we do have it, and model observability KPI is the one for every business team has that. Is an observability KPI is the one that every business team has that one kind of model performance improvement as their goal. But whereas that a team is platform team, and we do unlock it in more feature enablement for the user. And then also in given KPI, which is SLA target, and not guarantee that once we model is actually reliably training, and then do scale up for the more traffics. So those kind of system matrices are the ones being AI platform in charge. All right, I can go. Yes, so there are kind of 3 points of that I'm going to be talking today, which is the feature engineering part, and then model training, and lastly, in model retraining part. So before it, and few questions. Okay, which experiment tracking tool is used for the track model performance? Yes, we do have it built in-house mostly, and then we'll talking about it in retraining section. I will go over. And tools recommended for testing models. Yes, we do have it in-house in relevant of Sarah's question. And yeah, I'm really excited about passionate engineers. If you have more questions, yeah, feel free to contact me through LinkedIn. So feature engineering part is the one that's very, very important at Uber, because in earlier been talk about it and how important of the big data processing. So at Uber, we also have that big data processing, which is in feature engineering part. This one is being crossed over that data platform at Uber. We have a huge data platform teams at Uber who's building a good feature set. And then at the same time, we also have that a more focus on ML feature generation part, which is at under AI platform teams. So you can think about like, what is a feature? I believe everyone has a know about it, this basics. Yes, so feature, you can think about it, and feature is the one that input data for the model. So what does that in the given example today? So you take a ride today at 9 and 10 a.m. now, then you can have that once being 10 a.m. is the feature available. Or feature engineering part is a process of it. So you can imagine that once being 10 a.m. is it rush hour or not? This whoever has a domain knowledge about it and can interpret it and processing in a different way. Where so in that way you have a two feature, which is or not. This is the one that rush hour or the other ways. So this one is being kind of only known as an ML engineer or the applied scientists know about it in those domain knowledge. And then lastly, and we have it really good at in feature store, which is the commonly on that how many trips, what is that a user's cancellations in the past 30 days and during the rush hour. And those one is that all kind of feature store is computed. So we have a known, well-known Uber entities that are going to be computed on features. So then those features available for anyone. So these kind of feature store are the ones being shareable at Uber. And this one is really basic things, boosting up the model performance at Uber. Or it could be on outside as well. So feature store is the one, the first concept Uber provided at ML industry. And now and currently this one is well adopted concept in everywhere. So as I pointed it, feature engineering is the key part. We have it shareable at Uber so that it has it starting with that any common entities what we have as a CD or a rider or the driver partners. And then underlying, and we have a feature group, which is that big data processing happen. We're commonly using a Hive or over Spark or either in a Spark itself. And then those one have been processing a unit of the features in by data pipelines. Then it will be available for every user. So every day we compute and tend to be compute all these kind of Uber features and available for everybody for model training as well as the serving stack. You can imagine that there are two areas, which is that online part and an offline part. So you can think about it in offline is the big data processing, which is the data lake, which is Uber data platform providing a lot of data lake data. And then we do have it in a Spark job, additional Spark job to processing for the feature, which is that on palette feature is known as common entity, and processing it and also publishing those data and available for online, which is Cassandra is used as a low latency lookup for the serving piece. And you can see that OSP another batch prediction cases are going to be supporting from that Hive. So big area is the one that this flow and then how to handle for the big data processing for us. And then meanwhile, we also more touring into the near real time, which is through the Kafka topic and streaming engine is processing it. So minutes level or the seconds level and near real time feature computed and also available for prediction part. So go to the training part. Yes, we need that one's being GP, and yes, we need it for the online and offline part, and then near real time and offline features. Okay, so feature group is the one for notion of that a common entities at Uber, and we do have a processing, which is you can think about it in one single chip. We have it almost several hundred of model being used, and we can share that one's being common feature of the riders, common feature of that a drivers, which is when the rider is being joined Uber, what is the tenure of the rider, and what is that a trip requires to happen in the riders for the past 1 month, last week, and so forth. Yeah. So training part, and we do have it in this generation, as might be very interesting, aligned with Bin, and we trading very fast. And first we start with Spark ML, and then we do touring into a lot of deep learning model coming into picture, and a lot of business teams wants to do that deep learning model training. So we started with Spark, and then bolt on the deep learning use cases on top of the Spark. But then later on, we do have it in transform into the Ray as our infrastructure for the model training. So this one is being unlocking for the machine learning model, deep learning model. Now it's been generated with AI models. So model training and tuning, yeah, we do have a lot of problems. Why do we have it chosen array? And what is the biggest driver for Uber? So one thing is that we have a lot of big data processing to train the model. Then now we have it and very critical. We need that once being longer training time, as well as that we have to do that a resource constrained environment. So meaning is essentially we are evolving into the distributed model training and then recoverable fast and then scale well for the available resources. So with that, and we have it in unlocking all these end-to-end life cycle using all the tools and then enable those ML model use cases for across all Uber. So we have it a lot of business teams developing in their model. So I think I need to go a little bit fast. Skip it, and yes, we do have it unified ray-based ML and DL and an LLM model is happening it. So if you have been working with Ray and you already taken out our contribution in through the Ray, so building up a scalable solution training system by yourself and apply your systems. So I can take that one question. So Jagrat. Okay, and real-time meaning is that real-time meaning is yes, we do have a meaning inference of it. And retraining part is come in the picture. So now you have it, a model is being trainable And in a scale, you have a big data processing, all the features available in online serving, and as well as that a kind of model is available with big data. Then what is the next? So yes, in order to running a business, you need to be automated everything. We don't want to do that once being engineer or that crucial. Our resources in company are working on this repeated work. So retraining is coming the picture. Then if you think about like automated retraining, what is the challenge of it? Yes, it's coming that a picture with evaluation. What kind of evaluation we have is I'm gonna be talk to you. So with this type of evaluation, we are gonna be make it faster iteration for the model and then keep it on high quality model in production. So we call as an evaluation framework. So an abstract layer, this is all kind of in-house solution. So we have it in libraries, common library provided, and a user has that environment to creating a new library using a PySpark at the moment. And also Ray is also available. And we have a visualization tool set and storage layer being provided. So users just do kind of writing up the code for their evaluation strategy in case of the new or just using it old. So there are kind of three best practices. We do have a model chain and then offline evaluation happen, which is given offline data set. And we compare with a new model and production model and what is the performance of it. This is also kind of bare minimum. This one is been happening it. After that, and shadow happens, so that through the model being shadow, which is some given of a small portion of the traffic, go into the production system. And then it will go with validating all this prediction distribution is the right range of it. An online experiment happen, which is this is the one for the A/B testing, or either in that switchback testing. So you can do that once given cohort group and you can evaluating it. So it's not the end of it, model being deployed. And also we do check for the prediction performance and online and offline drift and feature drift. Everything is being checked and monitored. This one is being happen all these evaluation framework and come for free for everyone at Uber. So these are the ones being full landscape. I think I can skip a little fast. And full automation and reproducibility is going to be made it happen with all these flows. And top of it, we have it all this quality being placed, where the development quality and then production quality. So you can think about it, and all this one is matched with life cycle experience. We define the system quality as well as model quality, and then all this engineering quality are being captured well, so that it will be generated as a report and a visibility for everybody at Uber. So you can see that once being UI we provided. So through the UI, user can do that once being guided, and each is stage by stage. They know that once being how to build, what kind of pipeline to be built, and how to do that once being visualizing and access the data, and then train the model, and also setting up the monitoring is well guided and through the UI part. And we are in the version 0 release last year, and then version 1 was released this year. And then version 2 has been more focused on the generative AI. So this one will be a suite will be implemented as well. You can oversee what kind of feature, if you think about it in end-to-end life cycle from this slide. Okay, these are the ones been key learnings we have. We have a long journey happened from past to 8 years since 2016, and have reliability and scalability is the key part of the platform. And then building up the ML culture is really, really important, because all the talent in Uber, we want to do that, grow those talent faster, are going to be advanced our business as a success. And then tiering system is the one for that we can really focus on that high tier model, which is that business critical one, and then driving that a big impact at Uber for direct impact for Uber. So these are the 1.3 key area. We have a learning from the journey, and beside of that one platform area. So yeah, let's creating some ML masterpieces together. Have a question about is Michelangelo open source? Yeah, we are in process of the open source. So yeah, I hope that one we can meet you in person and as well as open source community. Thank you. Yeah, sorry about that in hurry.
Any more questions from the chat? Okay, great. So really thank you, Sally, for the presentation. Fascinating insights from Sally there.